Hey everyone, let's talk about Polish strings. Oh, what happened to the marker? Okay, so Polish strings comes under applications of stack, and stack, as we all know, is a data structure which follows first in and then last out. I mean, the first element to get into the stack is the last one to get out of the stack, or the last element which gets into the stack comes first out of the stack. So this is it. Okay, so let me give a little background about this. So we have the arithmetic expressions, right? Arithmetic expressions. So how do we really write them in real life? For example, a minus b, this is an arithmetic expression, or c multiplied by d, this is an arithmetic expression. So these expressions, they are in high level language, right? So these are in high level language. The goal is to convert them into machine readable form. So machine readable form. So what does this mean, machine readable form? This means that there is an assumption that an arithmetic operation can take place between two operands only. So if there are two operands a and b, so a mathematical operation, say addition, this can happen between only two operands. But what happens is, machine does not find it comfortable this way, because this is not the only expression that we have at hand. The expression could be as complex as this one, right? So machine has to deal with such expressions as well, or something more complex. So what happens is, we convert these high level expressions into what we call Polish strings. I think they are called Polish because they have their roots in Poland. So someone from Poland might have discovered that, so they have the name Polish strings. Okay, so nothing fancy about it, but yeah, this technique is really powerful, really. So Polish string, what is actually this notation? This notation represents, so we have, say, some expression, high level expression, which we also call the infix expression. So in order to convert this infix expression into Polish string, what we need to satisfy is that this is like the first point maybe, or the first condition. The operator is placed either before the operands, so operator, and then these are operands, right? Or, I mean, this one is the first point or second point. Either of them should be true, or operator is at the end, and then here are the operands, right? So this notation, since the operator is at the beginning, so this is called the prefix notation. Remember that we are seeing it in terms of the operator and not the operand, and this one is called the postfix notation. and where the operator is in between, for example this expression, this is called infix expression. Am I making sense? Have you got it? Alright. So let's see how to convert an infix expression to postfix expression. I have made this video before, but that was in English. I mean Hindi plus English. So I received a couple of requests to make the same video in English, but I thought that why not cover this topic in detail. So I am reconsidering this same topic and I'll use that same example, and hopefully I'll not miss D this time. So let's see how it goes. Alright. So let me explain you the rules first. So what happens is, while we evaluate the infix expression, we follow the following precedence. There is an order, evaluation order. So evaluation order is brackets or parenthesis, and then exponent, and then multiplication or division, and then addition or subtraction. Correct? So these are the operators that we consider in this order. I mean, this is the evaluation order as far as the operators are concerned. So these priority is also maintained in the conversion of infix expression to postfix expression. So that's why I have told you that that in infix expression we use this priority. So while we have this conversion, we should maintain this priority. So we'll see why, right? We'll see why in a short while. So I'll tell you two ways to convert infix expression to postfix expression, and now you gotta decide which one to use. There are two ways. There is a manual way, that is by hand, or there is a way using stack data structure. So what happens is, this manual conversion requires two passes, while this conversion using stack requires only a pass. So one pass is required for the conversion. So these two passes in manual conversion are, these two steps are, first one is the insertion of braces. So inserting braces where? In the given infix expression, and then the conversion happens because there are now braces, and then we can directly convert. For example, if there is an expression like this, so this is inside a brace, so I mean a parenthesis, so this is inside a parenthesis. So what we do is just write the operands and then operator afterwards. So this becomes a postfix expression. But you know, this placement of the brace or parenthesis, this requires a single pass. So this takes two passes, and then using the stack we have one pass. But then there is a problem of extra space, which is same as the number of operators in the worst case maybe. So we have to, like, you know, there is a trade-off between space and the time, right? So you gotta decide which one to use. I leave it to you, but I'll discuss the stack approach because that's what is interesting. So the conversion of infix expression to postfix expression using stack. So let's say, so infix to postfix using stack. So let's say the given infix expression is x. So this is the infix expression, and the output or the postfix expression is contained is, I mean, we get that expression in y. So this is the resultant postfix expression. So there are some assumptions while we do the step. So before that, what we do is, so this is say x, this is the input expression, and we place a parenthesis after this, not before this. And when we start the algorithm, we always place an opening parenthesis in the stack, right? So these are like two assumptions, this one and this one. We'll see shortly why these assumptions are there at the first place, right? So okay, so this one is the closing brace and this one is the opening brace. So you'll get to know why these assumptions are there. And we use a stack data structure to temporarily hold the operators for us. So let's start. And you know, like this y is the equivalent postfix expression for this given infix expression. So this y is not an alien here. So let's take an example and we'll see how it goes on. Let's consider that same example that we discussed in the other video. So the x was a plus b multiply c minus t divided by e exponent f multiplied by g and multiplied by h. So what we'll do is, we will place a closing parenthesis here, and now we'll have our symbol stack and expression y, or the result, or the postfix expression, equivalent postfix expression. So I told you that there should be an opening brace in the stack. So the rules are as follows. Whenever there is an operand, so this is an operand, the symbol is an operand, so just move it to the expression. So the stack is like this and expression is a, and there is an operator. So what happens is, like, this is an operator, so there is this opening brace, so we can place any operator straight away just after the closing just after the opening parenthesis. Okay, and then there is this opening parenthesis, and we can always place an opening parenthesis over any operator in the stack. And okay, I have forgot to update the expression. So this was the expression, and then b, this b is the operand, so just straight away move it to y, and then multiplication. So since this is an opening parenthesis, so we can always place an operator after an opening parenthesis. So multiplications move onto the stack, and then c is an operand, so move it to y. So this was AB and this was ABC, and then minus, and here the game becomes interesting. See, the rule is we have to follow the evaluation order that I described above. So see, this entire this entire thing matters a lot. This evaluation order is very important. This has the maximum priority, and then this has slightly less, this is less, and this has the least priority, right? So what happens is a higher priority member can sit on a lower priority member in the stack. See, here we have got negative, minus, not negative, minus. This is minus operator, and then we have multiplication sign here on the stack, and negative wants to enter the stack. So this, since minus has less priority, see, minus has less priority than multiplication, so minus can't sit on this operator, multiply operator. So what this operator would do, this operator would actually get popped out of the stack and would go into the expression. So minus will come here, and this multiplication operator would be placed here, right? So this might sound confusing, but just bear with me. You'll get the exact algorithm once we finish this entire thing. All right. So this minus is over, and then there's an opening parenthesis. Opening parenthesis does not create any fuss. They're sweet. So, and then D is an operand. So we move it to the expression Y, and then divide. Since this is an opening parenthesis, so we can place any operator over it. E. So same way, this is an operand, so this comes here, and then exponent. See, exponent has the highest priority. Do you remember that? Let me show the chart again. See, exponent has the highest priority. After braces, So exponent can sit over this. Alright. And F. So F would be placed right next to E. And then closing parenthesis. The game becomes interesting here. Listen carefully. Whenever there is a closing parenthesis, or brace, what happens is we go to the stack and we see which is the last opening parenthesis we have. So we have this parenthesis, the last opening parenthesis. So we pop every element out of the stack. So we have here is D, E, F. So this one is popped first. So this, and then division, and then this is popped, but this is not there in the expression Y, because Polish notations have this property that they do not contain braces or parentheses, and we'll explore it why is it so later on, but just keep this observation in mind. Okay, all right, cool. And then multiplication. So multiplication has highest priority, so higher priority than subtraction. And then and then G, this is G, and then closing parenthesis, the same story. This is the last opening parenthesis, so we pop everything out. So multiplication and then minus. Okay, all right, and then this multiplication. So multiplication has higher property than addition, higher priority than addition, so it can be placed onto the stack. Right, and then H, this is actually the status. So A, B, C, star, D, E, F, exponent, divide, G, star, minus, and H. And then in the end, this closing brace that we placed. Now you'll get the significance of this closing brace. So we have this closing brace right here in the end. So you see, this one was the closing brace that we put at the beginning of the algorithm, right? So this was necessary so that these two can match, right? These two should match. Okay, so we'll pop these two out and we'll get the final expression. The final expression becomes A, B, C, star, D, E, F, exponent, divide, G, star, negative, H, star, plus, and there is no brace here. So this is it. This is our final postfix expression that we have got. So this is our postfix expression for this infix expression, right? So yeah, let's see the advantage of Polish notations over infix expressions, right? Advantage of Polish notations over infix expression. This is like really important to know because I feel that people just cram the algorithm and then they're like, okay, we have crammed the algorithm, but we don't know why we are doing this. So this is really important. So what happens is, I told you previously that an infix expression is difficult for a machine to know because this precedence of the operators has to be known in advance to the machine. But what happens in a postfix expression? Postfix expression do not have any braces, and since there is this precedence of operators that is there, precedence of operators is there in the algorithm, so the entire expression is evaluated in a single pass and then there is no hassle. So the placement of operators is really good in Polish notations. So so for a machine it is very easy to carry out the evaluation of a postfix expression than an infix expression. So we'll see how to evaluate the postfix expression. I'll take a very popular example. So this example goes like this. So the given expression is the postfix expression. This is AB plus C star B divided by, and the values are given A2, B3, C4, B5, correct? So we have these value in place, and then we have to evaluate the expression, postfix expression, how a computer would do. So what happens in a computer is there is a stack. Okay, this is not a good color. There is a stack, and there is this. Since this, what happened in Infix to Postfix, we were putting the operators in stack. So what should happen while evaluating the Postfix expression? The operands should be in the stack. Are you getting my point? Are you actually resonating with what I am speaking? See, we have the in infix expression, we have the operator in between the operands. So these here the operands, here are the operands, and in between there is an operator. In case of this was an infix, and this is an postfix. The operator is here, and there are two operands. So to evaluate this expression, postfix expression, we need to have first the two operands, and then there is an operator. So while we get the operator, we should have the two operands at hand, and then we can perform the operation like this operand and then operator and then this operand, right? That's how we manually do it, right? So this is how the expression is evaluated. So we'll push these, so these can be maintained in the stack, right? Okay, let's see. So this is the first operand, this is moved in stack, and then here comes B. This is the second operand, so this moves in stack, and then there comes the operator plus. The things become interesting here. See, what happens is the stack is empty. Why? Because we have popped these two. Okay, my bad. We have popped these two and applied this operator in between them. So see, this was the first one into the stack. So this is the first operator. Are you getting it? Sorry, first operand. So we place it here on the left hand side of the operator, right? And then we evaluate it. A plus B, 2 plus 3, which is 5. So this 5 is pushed back to the stack. So the stack has 5, right? So this is the present situation of the stack. So we are done with this part, and then comes C. This is an operand, so move it to stack. And then comes multiply. This is an operator, so pop these out, C, and then 5, and then multiply, which equals, and what's C? 4. 20, right? And then this 20 is moved back to the stack. So the current situation is like this. Am I making sense? So we are done till here. Then comes D. Then comes D. This is pushed onto the stack, right? And then comes the last operator, division operator. So these two are pushed out of the stack so stack becomes empty. So D, and then 20, and then D was 5. So this result is pushed back into the stack. So the stack becomes 4, and then we go back. We are done till here. There is nothing left here. So we are done. When we are done, what we do is whatever is there in the stack, we just pop it out and display it because this is the answer. So the evaluation is complete. Evaluation of, what was the expression? AB plus AB plus C star D divided by comes out to be 4 when A equals 2, B equals 3, C equals 4, and D equals, okay, this was D, D equals 5. Okay, so this is it. I think I'm able to express my thoughts. If there is any doubt, do leave it in the comment section. I'll try to reply it. Okay, so stay tuned, stay learning. Okay, keep learning, keep smiling, stay safe. Goodbye.